My name is Gastone Castellani. I'm a professor of physics from Bologna University. My background is in physics and biology. Now I am a full professor of physics, biophysics, with a strong background in artificial intelligence. I started years ago in US because I was for 20 years collaborating with Brown University in US, where Professor Leon Cooper, that is a Nobel Prize in physics, started in the 70s about artificial intelligence, etc. So I had the opportunity to meet John Hopfield and also other famous researchers in artificial intelligence. Yeah, this is my background, my short CV. The Work Package 6 is a work package in the European project GenoMed4All that is devoted to artificial intelligence algorithm for the project. The major achievements are the release of the algorithm for imaging and tabular data, mainly genomic data, and also we implemented selected algorithm in a federated way. The federated implementation is very important because it's a hallmark of the project. We have not only this standalone algorithm, but also the federated algorithm. We don't want to solve all the problem for precision medicine because is out of the scope and the possibility of the project, but I can mention some results that in my opinion are very interesting in the perspective of personalized medicine. Let me start with sickle cell disease, because sickle cell is a not neglected disease, but not many people are working on this, etc. So we developed a particular algorithm for image analysis that was able to identify what are called silent infarct, and this algorithm has been validated with more than 500 magnetic resonances, and neuroradiologists are saying that this is a very important achievement, and so we are very happy with this. In the case of myelodysplastic syndrome, I can mention just two very important achievements. One is a genomic signature capable for distinguish between the risk associated to the progression in acute myeloid leukemia, because this is a very important step in myelodysplastic syndrome, because myelodysplastic syndrome in some case can evolve in leukemia or not. So it's very important to have a prediction about this. And we obtained this by using genomic data. And finally, in the case of multiple myeloma, a very important achievement that is the combination of medical imaging, basically positron emission tomography and computerized tomography, with genomic. We saw that prediction on overall survival, but also leukemia-free survival, is more precise if we integrate data from genomic and imaging. In all the European projects in which I'm participating, the main problem is to obtain the data, and this is requiring a lot of time. So in the next project, in the future project, I hope that according to the federated network we developed during GenoMed4All, we can save some time for obtaining the data. One positive outcome of GenoMed, I hope, will be to shorten this data availability. So basically, I hope we will be able to use the federated network to obtain access to the data without moving the data. Another legacy that in my opinion will be very important of GenoMed will be the extension to other diseases. because GenoMed was focused on hematology, and now we can use the same approach we used in hematological diseases also for other diseases like lung cancer, diabetes, etc. Now, there is a lot of research in the field of synthetic data. We have a project that is called Syntema, working on synthetic data generation and validation. And we will start in advanced position because we will have all the software and all the network for federated learning.